So second is like any sorts of like low-code, no-code solutions, like PyQt Designer. That's what I'm talking. Like because if when you use PyQt Designer, they give you all these tools so that you can use this to drag and drop and then generate the code. Which is very cool, but at the same time, it doesn't cover all the cases that the code can do, and it sometimes like generates like weird stuff, or like it will generate like a spaghetti code or whatever, so that it generates HTML first, and then I downloaded another library to change that to code. So this is the code that is generated. Right. So if you look at this code, you will see it's just like, oh, you have the tree widget 3 and tree widget 6 and tree widget 5.
Yeah, just the naming the widgets with numbered labels is not something we would do.
Right. So if we want to write this code exactly ourselves, we wouldn't write it this way, right? But now it's like, well, is this code. So do you want to clean it up yourself or do nothing with it? And say if I come here, I'm like, I don't like this naming convention, I want to clean it up. But if I want to add something in my original stuff, I can't, because you already changed this. So now the modified version of it, because it's not two-way like synchronized.
Yeah, it can't synchronize back into the XML file, and then
right, exactly.
Then you can't change it with the GUI anymore. Yep.
Right, exactly. So I feel like, well, that's just one example of the no-code, low-code solution. But there are other ones, like for example, the one we did at Insighton, like configurable form or something. Like you use JSON to define a form. Like what if
we also did one for converting the SharePoint data model to the database, to a database data model. We took like metadata that's coming from the SharePoint database, and we generated C# entity classes to represent database tables. Yeah, that's like a one-way street. You only generate in one direction.
And also, like when this kind of low-code, no-code solution have issues, you don't know how to fix it, because I guess unless you look into what's under the hood. But even if you look into what's under the hood and trying to fix it, maybe it's hard to fix it because maybe the under the hood structure is too complicated because of the abstraction. And then if you want to fix it, maybe you'll break some other stuff, or maybe you don't have access.
Yeah. It's like you don't want to fix it because I think because you don't want to make the code generator very complicated, because it's already complicated making a code generator. And if you add a lot of different options, different edge cases to it, it's going to make it more complicated and more difficult to diagnose. And you're in the first place, you're doing this to try to simplify your life. And now by making it more complicated, you're going to make it harder, right? So I think that's part of it. So like when things don't work out, you're like, oh yeah, I did not handle that edge case, but I also don't really want to add more handling.
Right.
So in Python, this is actually a Python 2 specific thing, which they have changed in Python 3. And this issue, this leaky abstraction, doesn't exist in Python 3 anymore. But basically the range function, like you're right, for I in range 10, and that's I is going to be 0 all the way up to 9. That's how that works. But then they realized that this is not good enough. And they added another function called xrange. And then after a while, they actually recommended people use xrange instead of range. So like, to me, that's a leaky abstraction right away, because it's like, to write xrange seems more cryptic than to write range. So why are we doing that? And why is that the preferred way to do it? And if Python's thing is make things simple, or give the illusion that things are simple, then why am I writing the more cryptic thing as the preferred method? That's weird. And then in order to understand why you want to use X range, you're going to have uncover more of how things actually work, what the secrets behind how Python works, right? So the reason is range returns a list of integers. Therefore, if you're going to use range with a large number, say 1 million, Python has to allocate enough memory to hold 1 million integers.
Okay.
That's going to be slow because the allocation of a lot of memory will be slow. And then later on, like reclaiming the memory will also be a little bit slow. Well, maybe not that bad, but just allocating a lot of memory is slow. So what X range does is X range doesn't actually allocate the memory for all of the numbers, but X range is actually a generator object or iterable object, and all it remembers its range and its current cursor within the range. So when the code goes back into the for loop will actually ask the generator again, hey, what's the new I now? And the generator just has to reply, the new I is this. So the generator can just use a counter internally to remember what the current I is, and then just increase it when the for loop asks it again. So it doesn't need much memory at all. It just needs a big O of 1 memory, whereas range requires big O of n memory.
Gotcha. So for I guess I would think the original range was like that to begin with, but I didn't know it's not.
Well, it is in Python 3.
Oh, okay.
They fixed it.
Okay, gotcha.
Yep.
Yeah, so I guess it's like for a developer who use Python, like how does the developer know like what is the stuff that's under the hood? I guess you can try to know it, but I guess then it defeats the purpose of making it easy to understand. I don't know.
It doesn't totally defeat it, but yes, but that's I don't know the answer to this, but like how much percentage of the time of staying ignorant is desirable? That's sort of what we're asking, right? Like how much percentage of the time staying in the simple life is desirable, because you can never really get to 100%. I guess you can get to 100% if you just refuse to learn the internals. Right. But that's gonna mean you don't have the ability to fix anything that requires you to understand the internals. And maybe you just like call a technician. That's what we do when we can't fix our car, right?
Right. Yeah, exactly.
So I'm going to call in somebody who knows what they're doing, and they'll do it. I'll pay them.
Yeah, I guess at the end, we can't always know the internal of all the tools that we use because we don't have that much time. So it's like, which one do you choose and which internal do you choose to learn? So.
Well, it's true that we don't have enough time, but that's like a deceitful way to look at. It's not that you don't have time. You only think you don't have time because what you choose to do is up to you, right? And so like when you say I don't have time, basically what you're saying is I don't have time because my time is reserved for doing other things. The framing it as I don't have time is basically you've pre-allocated your time for certain things. And what I'm saying is it's fine that you don't want to do it, but you should be more honest about why. And if you say, I don't have time, the real reason why is because you think there are other things that are more worth your time than this.
That is true. Yes.
And it's fine if that's the case. But if you say, I don't have time, that's sort of like a lie, because you I think you should be forced to confront the fact that, because a lot of times it's just like you just don't want to do this thing, right? It's not that you don't have time. A lot of times it's like, I just don't feel like doing this.
Well, it's like the choice of whether to use a library, right? I mean, most people use a library because they choose to prioritize maybe making the software quickly versus, say, implementing everything yourself. Using a library is faster. People make this choice. Probably people will know, say, if I use this library, I have to face this leaky situation at some point. Right.
You do one more and I'll do one more, and that'll be the end.
Okay. Which one? Maybe, well, I think all these are like similar, like say, like just using like a library versus using something that's more primitive or more low level. Because when you use a library, like say Lodash, you really don't know what's going on. And sometimes you do know what's going on, but you still do it because the code looks simpler or for whatever reason.
The code looks shorter.
The code looks shorter. So
and conspicuously, it might be because the underscore is a very short character.
Right. So you use the library, but the library is basically like a wrapper of what's under the hood, and you have to sacrifice maybe the optimization or something. So, and also when the library doesn't work, you might not be able to easily know why it doesn't work. Yeah. So that's the example of using library. I mean, this Axios.
MPJ did an episode on Leaky Abstraction, and he talked about Axios. Maybe let's talk. I kind of want to hear about garbage collection. What is our thoughts about garbage collection?
Well, when I write this, what I was thinking is, when you talked about in a language like C and C++, you have to do this yourself. You have to like clean up the memory usage yourself instead of, say, in JavaScript, it's like automatic. But when the garbage collection mechanism is like more automatic, you might face some situation of whatever you want to clean up, you don't. It doesn't get to clean up as you expected and things like that. So. Yep. Yeah, that's what and also I was thinking about, RSJS, why do you have to like unsubscribe whatever yourself, and how do you know when to unsubscribe? So and why it's designed this way, basically.
The times when the abstraction doesn't work for you in garbage collection is when you have a memory leak. That doesn't happen very often. I mean, okay, maybe it happens more often than you think, but it's not often that we diagnose the memory leaks. And my theory is it happens more than we think, but we don't notice it when it does happen most of the time, because it's not big enough of a problem that we need to fix it. But when it is big enough of a problem and we have to fix it, it's usually very time consuming. And also you're going to need to understand what a memory leak is and how it can happen, under what circumstances it can happen. What do you need to do for the garbage collector to properly do its job? You need to understand that, at least, even if you don't know the internals. In the game industry, they hit this more because performance is very important to them, because their game has to be smooth. The animation of the game has to be smooth. Basically, they feel like they have to take total control over this, so that they can, maybe like if they need to cheat someplace, they can, right?
Is that why they don't use JavaScript to develop games?
There are JavaScript games. It's not all of them. We have games. We have a lot of games developed in JavaScript now. We have a lot of Minecraft has a Java version,
Oh.
and Java obviously has a garbage collector.